In the previous video, we talked about the various ways to identify the variability of the data, and I was talking about the interquartile range. And then you must be wondering, like, why we are getting so much of the values, and then right, we understood range, we understood variance. Now we are trying to understand standard deviation, and then something comes up as interquartile range. What is this interquartile range all about? Now this interquartile range is actually the measure of the mid spread. While the range and the variability talks about how every point is separated from each other, range talks about the minimum and the maximum of the point. The interquartile range always talks about the mid spread, the middle 50% or edge spread. There are multiple ways you can call interquartile range. So descriptive statistics has all these names, right? So this interquartile range is the measure of statistical dispersion being equal to the difference between the 75th and 25th percentile, or between the upper and lower quartile of the data. And then you must be saying that, hey Sudhanshu, you are just coming up with n number of things for me, right? And I say no, let's understand this, okay, in a much better way. For example, if you talk about the interquartile, so let's say I want to pick up some data over here, right? I'll just delete the original values, and I would like to give you some numbers, right? So just let's say this is how it looks like. So I have a range, right, of values over here, and I have another value over here, right? I have one more value over here, and I have the last value is somewhere around this, and I will just take it this way, right? This way, somewhere around this. Okay, now just think, these lines are completely different, right? And when I say these lines are completely different, I mean to say that you have got different values on different lines. Now if you say that, if you just think this is the minimum point and this is the maximum point for this line. For similarly for this is minimum and this is maximum, this is minimum and this is maximum, and I have got only one column. I'm talking about this is only one column of the data. So some people get the package of say, so this is ranging from 4 lakhs, I'm just giving you examples, to or say $40,000 to say $65,000. Then one college is having the range of $40,000 to $95,000. One college has a range of $40,000 to say $110,000, and this college has a range of $52,000 to $78,000 range, right? So these are the multiple values which you can think of, right? But I want you to think in this perspective, right? How many people are actually, right, lying over there? So some people might be lying over here, right? Like most of the people are lying over here. Then there will be some people who are lying over here, here and here, and there will be several people who are lying over here. Now if I'm talking about the average value of the data, if I'm talking about the mean value of the data, I'm talking about the minimum value and the maximum value of the data, I'm talking about how on an average each spread, like on an average each point is varying from with respect to each other, and I also know where is the middle 50% of the people lying in this group, then probably I can tell everything about this data, right? So this is the guy who got the package of 4.2, this guy has got the package of 4.5, then this guy is the package of 4.7, and then so on and so forth. Now if I have a college where mostly people are actually very few people are getting this package, and mostly people are getting here the package, right? Mostly people are here, right? I can safely say that most of the population belong to this place, right? And these are very few people who are over here, like who are getting very high package, but most of the people are belong to this place, and my mean and median value might be somewhere here, right? Mean value will be here, and mean value will be somewhere here, and median value will be somewhere here, right? This value would be my median. But I can represent this data, right? I can just express my values over here. But I just think, just change your perspective a bit, right? Now instead of finding median, right, in the data, right, instead of finding median in the data, what if I divide my data? So just think, if I divide my data through median value, right, median value, my median divides my data into two equal frequency bins, right? I divide my data in two equal frequency bins, right? And right, so which means that number of elements. So this, if this is my I would say this is my median value somewhere here, then the number of elements on this side will be equal to the number of elements on this side, right? This is what we call it as a median, right? Now just think, if I divide my data into 4 equal frequency, I would say equal frequency bins, then I call that data as quartiles. I would say quartiles, right? If I divide my data into 5 equal frequency bins, then I would call them as quantiles, right? If I divide my data into 10 equal frequency bins, then I call them as deciles, right? And if I divide my data into 100 equal frequency, it's not 1000, it's 100 equal frequency bins, then I will call them as percentiles, right? Now out of this, right, I am sure like you must be knowing all of these values over here, but most important thing which we want to use is quartiles, right, which is dividing your data into 4 equal frequency bins. Now if you consider this, I'm just going to rub this off once again. If you want, you can just go back to the video and just look at the assumptions once again, but just look at this, right? If I divide my data into 2 equal frequency bins, what would happen over here, right? So I will have one value here somewhere, one value here, and one value is here, right? And how would this work? Which means that if there are like say 100 elements in this data, 25 are here, 25 are here, 25 are here, 25 are here, right? Which means that if this is 100% data, 25% of the elements are here, 25% of the elements are here, and so on and so forth. So this is my minimum value over here, and this value over here is my maximum value, right, whatever the value is, and this value over here, which is dividing this data into 50% over here and 50% over here, right, is my median value, right? So this is my median value. So I will call this as either median, I will call this as median, or most popularly I would be calling it as Q2, right? And this value, I'm just going to change the color so that you can remember that. Maybe I'll just look up for a fluorescent color, right? It will be, this one is Q1 over here, this guy over here, and this guy over here is called Q3, right? This guy is over here is Q3. So now if I'll just remove some of my art, which is very difficult for me because I'm very attached to my drawings right now. Just look at this graph, right? So this, in this case, in this way over here, right, if I pick up this data, this is my minimum value somewhere, right? And just assume that my Q1 value is here, and Q2 value is here, and then Q3 value is here, and this is my maximum value, right? Maximum value. So this is the representation of my data where I have 25% value here, 25% of the element here, 25% here, and 25% here, right? This is I'm dividing my data into 4 equal frequency bins. Okay, so this is the clean representation of what I have created. Okay, now what I want to do is I want you to just think in this perspective, that the way I'm showing you, right? I'll just make sure that this line and this line are equal almost, and then I'm going to draw one diagram over here, right? And that diagram is something like this. I'm making sure that I create a diagram something like this. Look at this, right? What have I done is, right, look at this. This is called box and whisker plot, right? And this value right there is Q3. I would not write it, right? I'll just this is Q3, and there will be a point, right, which will be my Q2, right? This will be my Q2, right? And this will be a point called Q1, and this will be my point for minimum value, right? This is minimum value, and this is maximum value. And this is called box and whisker plot, where this area of the total thing is called box, right? And this area over here is called whiskers, right? Whiskers. And this box and whisker plot is often used for univariate analytics, where you have only one column of data and you wanted to describe your data and you wanted to talk about it, right? Now, so you must be wondering, like, I was talking about interquartile range, and I'm now talking about the box plot. Now guys, this is the time to connect all the dots together. This is, my dear friend, is my quartile number 1. This is my first quartile, right? This value over here, from here to here, right? And then you have this value over here, which is my second quartile. This value here is my third quartile, and this value here over here is my fourth quartile. So your interquartile range, okay, interquartile range value is actually defined as Q3 minus Q1, which is nothing but the difference of the values which has been defined over here, which is like from here to here. This is your Q3 minus Q1, and it talks about this is your Q1, this is your Q1, and this is your Q3, and Q3 minus Q1 is interquartile range. And interquartile range, which is Q3 minus Q1, defines where the 50% of your data is lying. So now what I know about my data, I know mean of my data, I know median of my data, I know how they are varying with respect to, on an average, how much they are varying with respect to each other. I know their minimum and maximum value, and I also know the middle 50% of my data. So I know everything about my data, right? So if I just pick up the difference between 75th percentile or like 75% of my data and minus 25% of my data, where is my 50% of the data lying? And this is called interquartile range. If I know interquartile range, right, then I know mostly things about my data. So generally when you like go ahead and when you search for summary statistics, and Python does it seamlessly, so you just need to ask like summary statistics, and when you ask for summary statistics, Python will pick up one particular column, like whatever column you specify, and it will give you mean value, middle, like median value. It will always talk about Q1, Q2, minimum, maximum. It gives you, and very popularly it is called as interquartile range of the data. So this is your interquartile range, which actually helps you talk about the data more and more, right? So I hope you're getting some idea about what is interquartile range, right? And we are going to use this logic and this box plot a lot. I would like you to understand this in case you missed out any topic, or just rewind this video and learn from it, and because this is going to be very important session for you in upcoming times. And then I'll talk more on statistics. I'll see you in the next video. We'll learn more about the statistics. See you next.